Hey guys, welcome to the NCEA Level 1 Geometric Reasoning exam paper from 2020. If you're joining us for the first time, the way this video works is I go through each question and let you guys know what you need to do for Achieve Merit and Excellence. Best way to watch this video is to pause the video at the start of each question, have a go with the question by yourself, and then unpause the video just to see how far you actually go with your answer. Now, normally I don't really have any kind of sponsors or ads that pop up at the start of these videos, but this particular paper, I just feel like I need to actually say something. I get this feeling that this exam paper is actually sponsored by spiders. And you'll see what I mean by as we go through these exams. All right, guys, without further ado, let's get started. So before we start heading off into question one, I just wanted to kind of share with you guys how to actually set your calculator back, because your calculator might have been reset when you're just before you enter the exam. So it's really important that you actually know how to set the calculator back to the right mode. So just go into menu, actually not menu, you just go Shift Setup. Let's go to the normal kind of calculator, and then we're going to click on Shift Setup. And make sure that you guys have your angle where it says in radians. Just change it back to degrees. So just go down to where it says radians, and then just click on F1 to change it to degrees. This is really important because if you're working in radians, then your answers are going to get a bit funny. So it's just something useful to remember. And always a good way to check is if you actually put down sine of 90, you should get 1. And that's just a good way to remember whether your calculator is in degrees or in radians. Okay, so with that in mind, let's actually get moving on to question 1A, the geometry of spider webs. As I said to you earlier, that this paper is sponsored by spiders, but you kind of see there's a bit of a pattern that pops up. Now, unfortunately, I couldn't get this picture here, guys. I tried looking for it, but the paper on the website is actually without any pictures, so that makes it a bit more challenging. I looked up that link, but I couldn't really find it. So anyway, we should still be able to work through some of these questions without having that picture. All right, so with our first question, what we've asked to find here is calculate the length of x from P to Q. So we are pretty much looking for this length here, which is what x is. And the triangle that I'm going to be using is this yellow triangle, or the color of it, as you guys can see. So I'm just going to do a quick little check here, a quick diagram. So I've got 63 there, I've got x, and I've got 16.4 there. So what have I got to do? I got to try and work out using SOHCAHTOA. So labeling my sides, I've got hypotenuse here, and then I've got adjacent. So I'm going to be using cos rule. So what I have is cos of 63 is equal to adjacent over hypotenuse. So it's going to be cos of 63 is equal to x over 16.4. Then I cross multiply the 16.4, which is going to be 16.4 multiplied by cos 63. So just chuck that on the calculator. Cos 63. It gives me 7.445. So I can write down x is equal to 7.445 centimeters. Now, to get an achieved, you have to actually show some sort of evidence, which means I would say you probably need to do something along this line to actually get an achieved grade for this question. Okay, let's go to part 2 of this question. So part 2 of the question is asking for calculate the size of y of angle QSR. Okay, so QSR is this particular triangle that we're looking at, and we are asked to actually work out what angle y is. So once again, I'm just going to copy that quick sketch of the triangle, and my measurements are 7.5 and 16.4, and then I've got angle y right there. So once again, I'm going to use my SOHCAHTOA here to try and work it out. So I've got opposite, I've got adjacent, and I can see that I'm going to be using TOA. So that's going to be tan. So I can say that tan of y is equal to opposite over adjacent. So tan of y is equal to opposite, which is 7.5 over 16.4. And then I can say that angle y is inverse tan of 7.5 divided by 16.4. So I'm just going to chuck this in the calculator, shift tan, and just remember that I've got to open up a bracket for doing 7.5 divided by 16.4. And that should give me 24.58 degrees. So I can say that y is equal to 24.58 degrees. Grades wise, it's pretty much working as the same way. So you got to show some sort of working. And then, of course, your correct answer is going to get you an achieved. Cool. So moving on to the next question. Okay, so question B here, 28, 136, blah, 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 parallel lines. We are asked to actually figure out what angle P is. Now, the best way to do this is, there's a couple of ways of doing this. So what do I mean by the couple of ways of doing it? Okay, so the first method you could do is you could actually extend this line BD. Like you can kind of like extend it out like that. So, and the way I'm going to do this, guys, these types of questions, what I'm going to do is like, I'm just going to talk you through the answers straight up first. And then once I show you how I get the answers, then I can show you what type of reasoning that you can actually give. And I think that's how I answer these types of questions, is like I don't try and look for like reasoning. I try and solve all the angles I can. And then once I get all my angles that I need, then I go and find the reasons. So in this case, this is the first method you could do, right? So you can actually extend this and then put this as 28 degrees because it's alternate angles. And because that's 28 degrees, then you could actually go 180 minus 136 to get this angle, because that's going to be a straight line right here. So that part there is going to be a straight line. So 180 take away 36 is what, 50, no, 44. And then you can actually work out P is actually sum of 44 plus 28, which is going to be 72 degrees because exterior angle is the sum of the two interior angles. So that's one way you could do it. And I'm going to just kind of wrap it up. Sorry about that. The second way you could do it is you could actually add another parallel line here and then make this one 28 degrees. If that's 28 degrees, then this angle here is going to be 136 minus 28, which gives you 108. And then you've got co-interior angles, so this is going to equal 72 degrees. So yeah, you could kind of do it either way here. I'm going to stick to this method here. So what I'm going to do is I'm going to create this line, and I'm kind of sticking to the answer schedule there so that you guys can actually have a look at the answer schedule as well, just to see how it kind of makes sense. So that point there is y, that point there is x. And because I've already solved this, it's just a matter of like putting everything together. So the first angle that I'm going to do is angle BDY, and I'll color the angle so you guys can see where it is. So that's basically this angle here. And I can see that that's equal to 28 degrees because it is alternate angles in parallel lines, and that they're actually equal, right? So that's the first thing. Then what I could do is angle, I'm just trying to think what's the other way of doing this. Yeah, I think they've missed a step in, they've definitely missed a step. In fact, I think one of the answer, there's a mistake in the answer schedule, but that's all right. I'll just kind of work through this. The next step is I'm going to work on angle, let's do FDY. So FDY is going to be this color here, which is that. We can actually say angle FDY is equal to angle FDB minus angle BDY. So that's actually equal to 136. Take away FDB is 136. Take away BDY, which is 28. Which is going to give us 108 degrees. Now what I could say is angle DFE. DFE is what we're trying to figure out. BDF. Yep, angle DFE is the same thing as saying calculating off the angle P. So that is going to be here. Sorry guys, I know I'm trying to do a couple of things here and it's just so that, oh no, it's gone a different color, but you get what I'm trying to say. So that DFE is going to be co-interior angles that add up to 180 degrees. So that's going to be 180 take away 108, which equals to 72 degrees, because that's co-interior angles in parallel lines add to 180 degrees. Okay, so grades wise, we are looking at getting the final answer with at least one valid reason to get you a merit. Correct angle, so if you just get the correct angle, so if you just get 72, then you get an achieved. Or if you show like one of these steps to get to the answer, you could also get an achieved. Okay, so let's go to the next question. Yay, more spiders. Okay, so what we have got here is, you know, there's a whole lot of information here, right? Like, I'm not gonna lie. Like, whenever I see this type of question, I'm like, there's just so much junk here. I'm just gonna go right to the bottom, and it says calculate the length of W, right? So if I look at W, that's basically, they want to know the distance from here to here. Okay, if I want to actually work out that yellow colored distance, I'm going to need Jn. Now Jn is from here all the way down here, which is going to be part of this blue triangle. I also going to need Jm, which is going to be this part of the green triangle. So I can basically say that the blue height minus the green height equals the yellow height. So I hope you guys can see that. So the blue height minus the green height is actually equal to the yellow height. So that is what I'm going to do. So I need to figure out what the blue height is, and then I need to figure out what the green height is. So you can kind of see that you're working with two triangles. So first I've got the green triangle here, which is 12.5 and 32. And what I've got is opposite, hypotenuse. So I'm using sine rule. So I can kind of say that sine of 32 equals opposite divided by hypotenuse. Sine of 32 equals opposite divided by 12.5. So opposite is equal to 12.5 times sine 32. Whatever that is, 12.5 times sine 32. It's going to give me 6.624. So I'm just going to say, instead of opposite, I'm going to call it Jm. So Jm is equal to 6.624. Then I'm looking at the blue triangle, and I've got 21.2 and 9.4. This one, no need to use trigonometry, we just use Pythagoras. So we're going to call this b squared. So we can say that b squared is equal to square root, hypotenuse squared minus a squared. So b is square root of h squared minus a squared. Now you guys might be using something else, and that's absolutely fine, as long as you get the same kind of like numbers, then you're more than fine there. So b is equal to square root of that. I'm going to work that in the calculator. So square root of 21.2 squared minus 9.4 squared, and that gives me 19.002. So because this is Jn, then I can pretty much say that Mn equals to Jn minus Jm. So Jn is 19.002 minus 6.624. Let's just work that out. That gives us 12.378. What is all then? Centimeters. So grades wise, correct value of 12.378 with evidence of working gets you a merit. Achieved is either getting one of these two answers. So basically that's what's going to get you an achieved in this question. Otherwise, the final part of this question is a merit. Cool, let's go to the next question. Cool, so now this question is, it's doable, but it's annoying. Annoying, but it's doable. It's got a little bit of algebraic manipulation in it, so just got to be patient with me here, guys, but trust me, we'll work through this very slowly and we'll try and get to the end of it. So what the question is actually asking first is to figure out what f is, and that's this distance right here. Now looking at the units, I mean what we actually have, we don't have the height of this this triangle, right? We don't have the height of it. The only thing we have is 31 degrees, 41 degrees. So these are the things we've got. 31, 41, and the units, the centimeters, 36 centimeters. What we're going to have to do is split this up into two triangles. Our first triangle, I'm going to draw it in red, is going to be this one here. So that's going to be the red triangle. Then I'm going to get a, what color should I choose? Black, light green. The light green triangle is going to be outside. Okay, that's like a terrible one, but I just don't want to lose all my units there. Let's try this again. Yep, that's the light green, and then the red looks like this. And we're going to start labeling them. All right. So this is H. This is also H. The angles, we've got 41 there, and then 31 here. The base, we've got F. The base here, you've actually got 36 plus F. All right. So I hope you guys can pick that off. I'm looking at the base of the green triangle, not the highlighted part, but the green outside triangle, which is this right here. So it's going from there, from down to there is H, and then from there to there is 36 plus F. Next thing is we're going to write them up as two equations. All right, so what do I mean by that? We've got opposite and adjacent, opposite and adjacent. So we're using TOA for both, which is quite nice. So we can say that tan of 31 equals H opposite over adjacent. And on this side, we've got tan of 41 equals opposite over adjacent. Now, opposite in the green triangle is H. Adjacent is 36 plus F. And this is tan 31. Here, we've got tan 41 equals opposite, which is H, divided by adjacent, which is F. Now, we are actually trying to solve for F, which means we've got to figure out a way to get rid of that H, right? And so what we're going to do with H is we're pretty much going to rearrange both of these equations. So what do I mean by that? I'm going to get rid of the 36 plus F first to the other side. And when I get rid of it to the other side, it is going to become multiplied. And I'll write that in a different color. So 36 plus F multiplied by tan 31 equals to H. And same thing on this side. I'm going to bring F to the tan 41. So it'll become F times tan 41 equals H. So now what I've got is I've got two equations that actually equal to H. Because, so what you need to do is you need to think about it like this, all right? So imagine if we take this light blue part. This light blue part is equal to the yellow part. And if we've got another yellow part, and let's say this time I'm going to color this green. So what we can kind of say is, well, if blue equals yellow and pink pink equals yellow, then we can say that pink must equal to blue. If you're struggling with that concept, don't worry about it. Let me show you another way. It's like saying 3 plus 2 equals 5 and 4 plus 1 equals 5, which means we can say that 3 plus 2 equals to 4 plus 1. So that's pretty much what we're doing here. So if you think about it, we've got the blue part, which equals the yellow part. And then the pink part is also equal to 4 plus 1. So then we can say blue is equal to pink. And so with that in mind, I can pretty much say 36 plus f tan 31 equals f tan 41. So I've just put the blue part equal to the pink part. Next thing is I need to work out what tan 31 and tan 41 is. So I'm just going to work that out real quickly. So I've got tan 31 equals 0.6009. So this then is going to become 36 plus f multiplied by 0.609 equals f times tan 41, which equals to 0.8693. The next part I need to do is I need to expand these brackets. So my first one I'm going to get is 0.6009f equals 0.8693f. And then I've got 36 times 0.6009, which gives me 21.6324. Plus, now I need to rearrange, so I've got 21.6324 equals 0.8693f, take away 0.6009f. As I said, it's just a annoying little algebraic question, but this is what we can expect at excellence level at geometric reasoning. So we've got 0.8693 minus 0.6009, which gives us 0.2684f. And then we can say that f is equal to 21.6324 divided by 0.2684. So 21.6324 divided by answer. It gives me 80.59 centimeters. So as you guys can see, it is, once you set up that equation equal to each other, then it's just a matter of like moving things around to get the answer. So looking at this question, it looks like this question you actually get 2 E grades, so like you get 2 points for that. You could get an E7 or E8. Now look, what I'll do is I'll actually drop a video later on explaining the E7 and E8 a little bit more in detail. But right now, just think about it like this. If you get the 80.59, you're looking at a excellence grade. If you get up to this point right here, then you're going to end up with a merit. And achieved is getting to one of these things. So either this or either this. Actually, I should have done it here. Yeah, you got to have it in H. So either this or this will actually get you an achieved. Cool, guys. That is basically question 1. Alright guys, so we go with question 2, and as you can see, more spider webs. Clearly the examiner was looking at some beautiful spider webs when they were writing this exam paper. At least we think so, but let's get going with this question anyway. Alright, so we've got question 2A at the moment. What do we got? We've got to calculate the angle A. So as I was saying to you guys before, like how I tend to do these types of questions is like I actually work out the angles first. Once I work out the angles, then I actually write down the reasons and put everything together. So that's why it's a really good idea to just start sketching, like if you have a pencil, just to kind of roughly go over it, and then like you can just erase it and then go back and write your full answers. So kind of like this idea, I'm going to use it with like a light blue pen so you can kind of see what I'm trying to do here. Now, because we've got this angle here is 25 degrees, I know that this one here is going to be 25 degrees because it's an isosceles triangle, because that's a radius, so that's why it's an isosceles triangle. We got 25 and 25, that makes 50, which means the inside angle here is going to be 130. And if that's 130, A is going to be half of that because, it's whatever, like angle at a center is twice that it's at circumference and so on. So yeah, basically that's what it is. So you can kind of see that the A is equal to 65 degrees. Unfortunately, you have to show some sort of evidence of working to get an achieved grade, which, yeah, kind of sucks, but it is what it is. So what I'm going to do is I'm going to go and start working out on all of these things. So my first angle that I calculated was the 25, which was RPC, and I'm going to put down RPC equals to 25 degrees because its base angles of isosceles triangle are equal. Then I'm going to say angle PCR equals 130 degrees because angles in triangle equal to 180. Now what you could do is you could actually add that extra line. Like you could actually go 180 minus 2 times 25 to get to 130. And then we can actually go to angle PQR equals 65 degrees because it's angle at center. So angle at center is twice that at circumference. Yep. I am not a big fan of writing these reasons because like it's just so long, it's frustrating, but unfortunately it is what it's required at the moment. So anyway, that is gets you an achieved for that. Go on to the next question. Okay, so the next part of this question, what we've got is to try and figure out what we're calculating. Angle CED. I guess the first thing to try and do is to try and work out, because it's a regular pentagon, right? So that means like all of these sides are actually equal. So what we could do is we could actually work out what this angle is first, and then we've got an isosceles triangle inside of it, so we can kind of work it out from there. So looking at angle at D. So angle at D could be said as, like to find the angle, what you have is a pentagon, right? So basically the best way to do this is like, I mean, if you can remember the formula, great. If you forget the formula, then the best way to do it is like take one point. So I'm going to take like the top point, and I'm literally going to run to every other point, like a line through every other point. And then what I do is I look at how many triangles have I got there. Okay, so I got 3 triangles. I got 1, 2, 3 triangles. 3 triangles multiplied by 180 degrees is equal to 540. And then if I actually go 540, and how many angles have I got there? So I've got 1, 2, 3, 4, 5. So I go 540 divided by 5 gives me 108 degrees. So basically each of those angles highlighted in yellow is actually 108 degrees. Now if you're doing the formula, then you could just go n minus 2 multiplied by 180 and then divided by 5. I think it's like the number of sides goes at the bottom. I think it's like this if I remember correctly. So we've got 5, take away 2, multiplied by 180, divided by 5. And it's the same thing as what we did before. You're going to end up with 108 degrees. So angle D is equal to 108 degrees. Now if that's 108 degrees, then we can actually say X is equal to 108T, take away 108, divided by 2. And why is that? Because sum of triangles. So angles in triangle equal to 180 degrees. So yeah, so doing that gets you 36 degrees. Grades wise, we're looking at and achieved for this. And again, you got to show some sort of working for this. Cool, let's go to question C. Okay, so with this question, what we're trying to actually trying to prove, not prove, we're trying to figure out whether FSJ is parallel to GCT. So FSJ is this line here, and then GCT is this line. Now, it's really important that you look at the diagram and go, well, that doesn't look like parallel line, and just leave it at that. You've got to prove it with some sort of numbers, right? And I guess the big clue here is are both tangents to the circle at the points S and T. Now, one of the rules is that if there's a tangent with a line that's actually going to the radius, and that ends up being, the angle ends up being 90 degrees. So in other words, we can kind of say that angle JSC, and I'll color it in for you guys so you guys can see where that is. So JSC is right there. JSC is actually equal to 90 degrees. And the reason it's 90 degrees is because angle between tangent, long reason coming up, and radius is a right angle. Just going to put that as a little symbol like a right angle there. Actually, you know what? Let's just be safe. Let's actually write the word down. There we go, right angle. Now, if JSC equals 90 degrees, then we can also say that FSC equals to 90 degrees because angles on a straight line. Just to kind of give you guys where I got that from, let's see, what are the colors haven't I used? So I'm looking at FSC, which is that part right there. And because if that blue angle is 90 degrees, the orange angle has to also equal 90 degrees. Now here comes the problem, right? We can kind of say at this point, since angle FSC is actually not equal to angle SCT, because FSC is equal to 90 and SCT equals to 100. And if they are parallel, if JSF and GCT are parallel, then angle FSC plus angle SCT should equal 180 degrees as they are co-interior angles. I mean, you could have done it the other way as well, like where you could have used as alternate angles. But this is just another way. There's heaps of ways to kind of do this question. But this is just showing one way there. So required angles found at least one valid reasons. Gets you a merit, gets you a 90 degrees. Getting a 90 degrees up there with the blue is going to get you an achieved for this question. Cool, let's move on to the next one. All right, guys. So we've got pretty kind of like a pretty weird looking question, but like let's just kind of break it down and try and work this through one step at a time. Okay, so the first thing we're gonna do, I'm gonna have to put some sort of, I don't even know how I'm gonna color this in, but like I'm gonna try this. All right. So number one, we've got to actually work out this angle first. Because what are we looking for? Let's actually try and work backwards, right? If you're going to try and work backwards, will that help you? Let's see. So we want to try to figure out the radius of the circle. So we're basically looking for this length here. Now we've got this 18 outside here, right? So it's possible that we're going to have to create some sort of triangle like this. So if we have that 18, and if we figure out what this angle is, then we can use trigonometry to actually work out what the green is, the green side is. So we need to work out what this black angle is. Now to work out the black angle, we know that we could get this pink angle. Then I'm just trying to see the best way to do this. Then we also got a light blue angle, which is this one here. So we can get the light blue angle from the 108. We can get the pink angle from taking 360 minus the blue. And then we can work out the black angle by halving the pink angle. Using the black angle and the 18, we could actually work out the radius, sorry, the green side. Hopefully that made sense, but yeah, let's see how we go about this. All right, so I'm going to work out the blue angle here first, which is angle MCN. Now that's equal to 108 times 2, which is 216 degrees, because angle at center is twice at circumference. Then we've got the pink angle, which is going to be angle MCN, the inside of it. So I hope that kind of makes sense, which is equal to 360 minus 216, which equals to 144, and that's because it's angles at a point. Next is working out the black little angle. So the black angle there, I'm going to call it angle MCQ. MCQ is equal to 72 degrees. And the reason it's 72 degrees is half of 144. Because we can say that line PC is kind of cutting it right through in half. So it's cutting the angle MCN. Now we still need to prove that PMC is 90 degrees. So that's going to be, which color should we use? Let's use lava color. There we go. So the lava angle there, we need to prove that it's 90 degrees, which is angle PMC is equal to 90 degrees because it is angle between tangent and radius is a right angle. Cool, and I think now I've got everything I need because there's my little triangle where that's 18, that's 90, that is 72 degrees. And then this is what I'm looking for, which is the missing side. I'm going to put that as R because it's radius. Then I've got opposite, adjacent. I'm using tan. So I can say that tan 72 equals opposite, which is 18, divided by adjacent. Let me just do that extra step there for you guys. So we've got tan 72 equals 18 divided by radius. Swap over, so you're going to get radius is equal to 18 over tan 72, which means R is equal to 18 divided by tan 72, which gives me 5.85. And that ends up being the radius for this question. So grades wise, we're looking at a merit for this question. Finding two angles from this whole series gets you achieved. So 2 angles gets you an achieved. Sweet, let's go to the next question, guys. I know I kind of went through this real quickly here, but like, let me just kind of reiterate that how I jumped from here so quickly. So when I had tan 72 equals 18 over r, I brought the r across, so that's going to become r times tan 72 equals 18, and then r is equal to 18 divided by tan 72. So it's kind of like, just, I know I kind of skipped through that step just in case if people didn't understand how I did that. Okay, let's go to the next one. All right, guys, so with this question, how would you go about doing a question like this? You could kind of play around with numbers a little bit if it makes it easy for you guys, and then replace it with numbers. So what do I mean by that exactly? I mean, I don't think it really matters in this case because it's just so many lines going everywhere. But I'll try my best, all right? Like, in fact, I might just stick with the letters to try and figure out. I've got a W, and I need to kind of write that in terms of X and Y. One thing that I do know is if I can figure out this angle here, I could just go W minus 180 minus W, and the red angle, that's going to give me what W is. Now to get that angle, I've got Y already there, so I'm going to need that other side, opposite side of it, right? And I'm going to see if I can try and get that in a different color. That'll give me an actual pink color. Yeah, let's go light pink. So I'm going to need this angle here, right? To get to the red angle, I'm going to need the pink angle. Now to get the pink angle, I am going to need this angle here, light green, and I'm also going to need the light blue. Oh. Now what I also know is, if you guys look at angle X right now, angle X is the same as the light blue angle. Now, how do I know that? Bear with me, all right? Because this is going to be a bit weird, but it'll make sense. So notice how this angle is on the same arc as X. And the arc that I'm looking at is this arc. I hope you guys can see that. So you can kind of see that the light blue angle is actually equal to X. So the light blue angle is FBA is actually equal to X. And because its angles on the same arc are equal. Okay, so that's equal to X. I'm going to rub it out, guys. So I'm going to rub all of this out so you can kind of see that that's X. Now I need to figure out what the green angle is. Now to figure out what the green angle is, I want to see what other information I've got here. I've got an isosceles triangle here. The isosceles triangle is this right there. Because as you can see, there's a line there and a line there, which means I'm going to use, what color haven't I used? Red, I've used black. Let's go black. This right here is going to equal to X because it's base angles of an isosceles triangle. So I'm going to write that. So it's FAG is equal to X because base angles isosceles triangle are equal. Okay, so once that's done, I'm going to get rid of the yellow part of this. So hopefully you're with me so far. Next, I can actually work out what the green angle is. Now to work out the green angle, notice how the green angle is on the same arc as X here. And the arc that I'm looking at now is this part of the arc. I hope you guys can see that. And so that was the light green, is it? Or dark green? Whatever, light green. So that's angle EBA. F is also equal to X because its angles on same arc are equal. Okay, so I'm going to take out the green highlighted part. So I've just figured out that this is also equal to X. Now I can work out the pink angle, which happens to be EBD, which is actually 180, take away 2 lots of X, because its angles on straight line. So that's going to be 180 take away 2x. Now I can't really do anything with it. I'm going to leave it as it is. Next, I'm going to work out the red angle, which is angle DEB, which is actually 180 minus y and minus the pink angle, which happens to be 180 minus 2x. Okay, so let's do that. We're going to get 180 take away y minus 180, and of course negative times negative 2x is plus 2x, and what we're going to get is 2x minus y. So that red angle there is 2x minus y. So finally we can then say w plus x plus what do we got, 2x minus y. All of that is equal to 180 degrees because angles on straight line equals 180 degrees. So then we can say W is equal to 180 minus x minus 2x, and plus y, because I got to change those symbols, right? And then I can say W is equal to 180 minus 3x plus y. So, you know, like it is a bit of a long question, but it's not too bad. But it's just, you know, you got to kind of learn how to pick those isosceles triangles and angles in the same arc. And I think once you do that, you should be pretty much well on your way. It looks like another one of these double E questions. So if you get the final answer correct, you actually end up getting 8 points. Finding 2 angles involving calculations, including x with at least one reason. So for a merit, you need 2 angles and 1 reason. For achieved, looks like 2 steps having substitute a numerical value for x. So you can actually just put x as a value and kind of like use that to work around. And I think it basically says that like one angle gets you a achieved, or kind of like doing a couple of steps with a numerical value. So you could put like x equals 40 and kind of have a play around with it. Yeah, cool. That's basically it for question number 2, folks. Okay, so we go to question 3, and surprise, surprise, more spider webs. As I said, sponsored by Spiderwebs, this exam paper. Anyway, let's get going to question A. Get straight into it, folks. What do we got? We're trying to figure out angle P. Right, so we got a bunch of parallel lines here, right? And again, I'm just going to do a quick rough check here. So because it's 64 degrees as DBE, this one here is going to be 64 degrees because it's alternate angles. This one here is going to be 64 degrees because it's looks like an isosceles triangle inside of it there. So those 2 angles are going to equal each other. Then we're going to figure out, what do we got? 180, take away 64, 64, that's 52, is it? And if that's 52, we're going to end up with 64 here. Yeah. So pretty much it. Or you can actually do corresponding angles. Oh yeah, we could do corresponding angles. A good point. We could do corresponding angles. Okay, let's do this one. So first off, we've got angle BDA equals to 64 degrees because our reason is that it is an alternate angles equal in parallel lines. That's our first one. Then we've got the red angle, which happens to be DAB, which is equal to 64 degrees. which is going to be base angles in isosceles triangle are equal, and then we're going to write down angle EBC equals to 64 degrees because its corresponding angles in parallel lines are equal. Again, you could have done the other way that I was working with, which is, I mean, it's one extra step, but still you could have done 52, and then because it's angles in a triangle add up to 180, and then you could go 180 minus 52 minus 64 to get the blue angle as well. All right, guys, so grades wise, you're looking at an achieved for this, with of course showing some sort of working for this as well. Cool. Let's go to the next question here. All right, guys, so question B, what we've asked to find is the perimeter of this trapezium. So we're actually looking for two kind of measurements here. So we've got to actually figure out what SR is, and then we've also got to try and figure out what TS is. Now looking at this, this is similar triangles, all right? So with similar triangles, what we need to figure out is, there's actually two triangles in here. So we've actually got this blue triangle, which actually goes like this. And then we've got a green triangle, which is very similar to it, but just like a little bit bigger. So what we've got to try and work out is how big is the green triangle compared to the blue triangle. And so what I'm going to do is I'm only going to focus on the measurement that's actually here for the blue triangle and the measurement that's actually here. So it's basically taking that green length, dividing it by the blue length is going to give me the ratio. So I'm going to go into my calculator and I'm going to go 28 because the green length is 20 plus 8 and divide that by 20, which gives me 1.4. So from here I can say that the ratio is equal to 1.4. And because it's 1.4, I can actually work out what TS is. TS is going to be 12 times 1.4. Well, not TS actually. I'm incorrect. I've got to work out what PS is first. So if I was to repeat it on the other side, right? So what's going to happen is I've got 12, which is from up to here to here. Then I've got PS, which happens to be from here. So I can kind of see that PS minus 12 is equal to TS, which happens to be that red one there. Now to work out what PS is, I can actually say that it's 12 times 1.4. So it's going to be 12 times 1.4 minus 12 is going to give me the length of TS. So 12 times 1.4 minus 12 gives me 4.8. So TS is actually equal to 4.8 centimeters, which I'm going to write down here. And I'm going to repeat the same process for SR as well. But the cool thing with SR is it's just 9.6 times 1.4 because that's just increasing by a ratio. So we can just say SR is equal to 9.6 multiplied by 1.4. So when we do that, I've got my calculator somewhere. 9.6 multiplied by 1.4, it gives me 13.44. So with that in mind, now I can actually work out the perimeter, which is 9.6 plus 8 plus 13.44 plus 4.8. So on my calculator, I got 9.6 plus 8 plus 13.44 plus 4.8 gives me 35.84. Okay, so we don't actually need to justify that it's similar triangles, so we can just leave it as it is. Grades wise, final perimeter is going to get you a merit. Getting one of these lengths is going to get you an achieved, all right? So that could be PS, That could be 4.8 or could be 13.44. That's what's going to get you an achieved for this question. Cool. So let's go to question C. Okay. So WT is 80. Show the height BT is 16.63. So I guess we're looking at this triangle right here for this question. So BT is right there, and the triangle we're going to be looking for is this one, this pink triangle. So if I'm just going to kind of like draw it out, so I've got 80, I've got 12, and I'm trying to figure out what BT is, which is the height. So taking it here, I've got opposite, and I've got hypotenuse. So I'm going to be using sine. So I've got sine of 12 equals opposite over hypotenuse, and then sine of 12 equals opposite, which happens to be BT, and the height, which is 80. Cross multiply, I'm going to get 80 times sine 12 equals BT. So 80 times sine 12. As you guys can see, it equals to BT equals to 16.63. This is a nice achieved question because they actually give you guys the answer. And as long as you're able to show the working, you are pretty much going to get an achieved for this question. Moving on to the second part of the question. We're looking for the angle of elevation of T above S, angle TSB. So to give you guys a bit of an idea, angle TSB is going to be on the red triangle, which is facing the outside, the back side almost, if you can. So I'm just going to get rid of the pink triangle because we're not using that anymore. The red triangle. Now we've just figured out what BT is. We also have another triangle that's actually kind of, how do I say this? It's like kind of like lying down on a bit of an angle. That's this one here. So the 80, 120, and we can use Pythagoras to actually work out what ST is. So that's what I'm going to do here. So I'm going to work out what, so that's STW, where this is 80 and 120. And then if you look at my red triangle, I've got STB, and we're trying to find the angle TSB. So we're looking for this angle, and we've figured out what TB is, which is 16.63 from the previous question. So if we figure out what TS is, which is this length, we can actually work out what angle TSB is. So it's a twofold question, right? So we got to do the TS first. So we can say that TS squared equals 80 squared plus 120 squared because it's using Pythagoras. And then TS is equal to square root of 80 squared plus 120 squared. I'm just going to go straight into the calculator and chuck this on. So I've got shift square root of 80 squared plus 120 squared, close the brackets, and I'm going to get 144.222. Now that's what TS is. So I'm going to replace 144.222 here. And what have I got here? I've got opposite and I've got adjacent. So I am using TOA, which is tan. No, I'm not doing that. What am I doing? It's opposite and hypotenuse. I'm like, that doesn't look right. Yeah, it's late in the afternoon, folks. So we're using SAW because we're trying to figure out what the angle is. So we can say sine of x equals opposite over hypotenuse. Sine of x equals 16.63 divided by 144.222. And then x is equal to inverse sine of this beautiful number, whatever that is. Let's work it out. So shift sine of 16.63 divided by 144.222, and that gives me 6.62 degrees. Cool, guys. So grades wise, 6.62 degrees with enough working to confirm that this could be on the diagram gets you a merit. 144.222 gets you an achieved. Consider that angle S. Yeah, it's a bit weird. Like, let me just show you guys the answer schedule. I'm trying to decode it. So it basically says the correct value gets you 6.62, right? But then here, showing with evidence of consistent working that is 6.62. Yeah, I'm not sure how this like, I mean, you get 6.62, you should get merit. I don't know why it kind of sticks here with an achieved. Um, yeah, not really sure where that is coming from. But anyway, we will kind of just move along. As long as you get the final answer and you've got enough working on it, you should be fine for this question. Cool, guys. Let's go to the last question. I gotta say, folks, like whenever I see bearings questions, I know I used to work with 11 kids who would be like, "Oh, I hate bearings, sir," and I'm like, "Man, bearings is like the most coolest thing to do because why? It's just a bunch of right angle triangles just layered on top of each other, and as long as you know how to decode them, this is probably one of the easiest excellence question you can actually end up getting in geometric reasoning, especially when I see bearings. I'm like, man, that's cool because that's going to be like a guaranteed excellence question. So what are we actually, what are they asking in this question? They're asking us two things, all right? So we've got direct distance uh, of S from F. So it's like basically we're looking at S and F. And then we're also looking for, what are we looking for? We're looking for the bearing of S from F. So the second part of this question is we're looking for the bearing, which is, let me just kind of draw this again, which is basically this angle here. Okay, so that's what they're looking for as the final answer. So what are we going to do is we're actually going to create a bunch of right angle triangles. Now, luckily, this one here, it's not too bad because you've got an angle there, so you can almost create this little right angle triangle there. So I hope you guys can see that. And we know that 140 is the actual hypotenuse, not the blue line, but rather the black line here. Okay, so that's pretty much our first kind of like step there that we have. So I'm going to use the blue triangle. I'm going to kind of break it down first, right? So I'm going to work out the blue triangle, which is right there. That looks like this. This is 140. This is 78 degrees. And I'm going to put this point right here as N. So that's N, H, and F. And I'm going to work out what NF is. So NF is going to be opposite hypotenuse. So we're using SOHCAHTOA. So we can say sine of 78 equals opposite over hypotenuse. Now opposite is NF. Hypotenuse is 140. And then we've got sine 78. Don't know why I'm working with this in. There we go. Then cross multiply, we've got 140 times sine 78 equals NF. So I'm going to go to my calculator and just work out those numbers. So I got 140 multiplied by sine 78, which is giving me 136. So NF is 136.94 centimeters. So I'm going to put that out here first. Now, to work out the green distance, SF, I've worked out this part here, right? And I guess what I can do is I can create like a right angle triangle because this part here is worth 54. And I need to work out what this part, the orange part, is to create a big right angle triangle, and I can actually work out what the green part is. So the next step is I've just worked out the blue part. The next step is I'm going to work out the orange part. Now with the orange part, you could actually use Pythagoras or trig. It doesn't really matter because you've got enough information there because you got 136.94, you got 140, and you got 78 degrees there. All right, so this is NHF. I'm going to use Pythagoras, so I can say that NH squared equals 140 squared minus 136.94 squared. So NH equals square root of 140 squared minus 136.94 squared. So which is going to give me, what do we got? Shift square root of 140 squared minus 136.94 squared, which gives me roughly 29.11 centimeters. So with that in mind, I can actually work out what the green part is, because if you think about my big triangle there, I've got 136.94, which is N and F. Then I've got S at the bottom there. Now the pink part is up to there, which is worth 54. The orange part, which is up to there, was worth 29.11. So 29.11 plus 54. And then SF, you can see that it is another Pythagoras. So I could go SF squared equals, now I'm just going to write down 29.11 plus 54 first. So that's 83.11. Again, I'll color everything so you guys can see what's happening. Yes, I love highlighters. I would recommend you guys to use your highlighters in your exam papers. So we've got NF squared plus NS squared. So SF squared is equal to 136.94 squared plus 83.11 squared. So SF is equal to square root of this, whatever this number is. Let's just work it out. So we got shift square root of 136.94. Might just want to put a bracket in there. Squared plus 83.11 squared. That gives me 160.19. So far, so good. Now, we've got the green part, which is the direct distance. Now we need to work out the yellow part, which is the angle, right? Now, here's the thing. Let's actually draw this triangle again. There's my light blue part. There's my green part. And there's my pink and orange part. And as I said to you guys before, the angle that I'm trying to work out is this angle here, which is going around. Now, I already know a couple of things. I know that this is 90 degrees. And if I work out what this angle is, then I can go 360 minus 9 minus that pink angle. I'm going to get the bearing, right? So that's what I got to do. Measurements, I already know what they are. I've got a 136.94 and could use 83.11. You could use any one of these measurements. It doesn't really matter. So I'm going to use tan. So I'm going to use opposite and adjacent. I'm going to call this tan, like I'm going to put this as x for now. So then I can say tan x is equal to opposite over adjacent because this is TOA. Then I've got tan x equals 83.11 divided by 136.94. Then x is equal to inverse tan of 83.11, 136.94. So that's going to give me 31.25 degrees. So x is equal to 31.25 degrees. Then I can say bearing is equal to, so I can say that bearing is 360, take away 90, take away 31.25 degrees. So I've got 360, take away 90, take away 31.25, gives me 238.75. And of course, I've got to round it up for bearing in this case. So it's going to be 239, a bearing of 239 degrees. So I'm kind of hoping that by showing you guys this picture, like this big long picture, is that the way to approach these questions, these bearing question, is to stack a layer of right angle triangles on top of each other. Sometimes you get to create like 3 or 4 right angle triangles, but that's all it is, guys. When you see bearings, and if you're super confident when using your SOHCAHTOA, then you should be nailing bearings questions, because all you have to do is just break them into little triangles, and you get to kind of work through them. Now, I have got in my playlist, like there's a bearings, there's a 3-part video mini series that you can watch, just to kind of like how the bearings work from the beginning till the end. And I would strongly recommend you guys to kind of watch that if you want to nail this question here. So grades wise, it looks like another double excellence question. So minor error gets you like a E7, which means 7 points. Otherwise, what do we got? Bearing of 239 and FS of 160.69. So for excellence, you got to get both the bearing and that. For merit, getting one of them. So merit could be like bearing or distance. And then achieved looks like a whole bunch from like any one of these things. You could potentially get an achieved for it as well. Yeah, just last thing is like going to the exam paper, as you guys can see, when they talk about cut scores, basically you need like 8 points to get an achieved. Like that last question that we did, if you get everything right in the last question, then you end up getting like 8 points, because that one question, just doing that one question will get you an achieved for this entire paper. So yeah, that's just something to keep an eye on. What else do we have here? Yeah, so overall it wasn't like a too complex of a paper. It was just fairly straightforward. I still feel like TEG is still a bit of a nightmare compared to these ones. Yeah, so my recommendation for this paper, guys, is that like if you're struggling with the reasons and stuff like that, just do substitute it with the numbers and just try and figure out all the angles, because sometimes that might just trigger a memory or something like that to say, hey, what about this one? You forgot to actually put this one in here, and you can kind of have a go with that. Yeah, so I just want to say good luck for your guys' exams, and catch you on the live streams. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course, subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Good revision material. And as always, thank you for watching.